Hello, everyone. Welcome to the last session of today, I think. Welcome to this talk on the end of the data ice age. This is it's kind of a fun topic that came to mind for topic for a talk. So I hope you find it interesting. My name is Hugh Mckee. I'm a developer advocate at a company called Lightbend, company behind Scala, Akka, things like that. And anyways, I want to talk to you about something that came up as I was working on something new that my company's doing that got me thinking about how we write software. And it was really that the thought that kind of came across my mind that inspired this talk was, why is it in the third decade of the 21st century is the way we compute so much still influenced by the way computing works, like at the hardware level? So this is kind of an abstract, picture here, but the idea is that there's a lot of, we've got tons of hardware that we can run on, cloud and everything. We have, infinite capacity these days. We also have infinite storage as well. I mean, storage has been a great story, but they're kind of in our face, I thought, in the way we write code. And I've been writing code for a long time, and it's like we've been doing this for decades. And it's like, man, it's like the third decade of the 21st century. I know we're off to a rough start in this decade, but shouldn't we be doing things a lot better? So the thing I've been working on that kind of inspired this was it's kind of a software abstraction. I'm going to show you a little bit about it. And just an example of it. I'm not really here for the specific abstraction. It's more about the concepts here that I wanted to talk about here. But a lot of my slides, I don't know if anybody uses Blender, but I love Blender. It's an open source 3D application. People do like movie quality videos with it, and it's just amazing what people can do with it. And while I was preparing this talk, I came across a YouTube tutorial that was this image, and it was exactly the way I kind of had in my mind how this software abstraction works. So hopefully what this picture conveys, you'll have a better understanding of it by the end of the talk. And really this is, as I said, this new way of kind of doing this abstraction was, could this be the end of what I'm calling the data ice age? So what's that? Well, just real quick, I mean, for backend systems for a long time, as part of the 12-factor app is, you write stateless applications. And the great thing about stateless is, there's a lot of great things about stateless, but one of the great things about stateless is it's very easy to scale up and scale down. If you need more processing capacity, you do that. But there's kind of two levels here. There's kind of a compute level and there's a data level. So, with stateless, the idea is that when a request comes in to perform some state-changing operation on some data, that data is retrieved in one of the instances of your application, stateless application. You get a copy of that data basically, because the master of the data is really at the database level. But the code is the place where we change the data. So in this little example here, say one request comes in, it gets a copy of the data and it does its work on it. But then say another request comes in for some other piece of data in one of the other stateless instances, so it retrieves that data. But then another request comes in that retrieves that same piece of data. So I'm just calling it data v3. So there's two pieces of data here, but these two apps both have a copy of that same data. No problem. We know how to deal with this. I'll say the first instance makes some kind of a state change and posts the changes down to the database, do an update, and like some kind of form of optimistic locking, the version of that data now has changed from version 3 to version 4, something like that. But then the other instance goes, okay, I made my state change, now I'm going to save that change, and it gets rejected because it's got an old copy of the data. Also no problem. Typically we know how to deal with that, but it's this whole kind of, in our development of the software as developers, this is all a big part of what we do, right? And is there a better way that we can do this? So The other thing I've been kind of thinking about here is that there's this idea of hot state and cold state. And this is where I came, kind of thought about the ice age, that when data is stored in a database, it's kind of frozen. You're not changing it. In order to change the data, you got to pull it out of cold storage and put it up into compute space so that you can change it. But if you really think about it, wouldn't it be nice if in the way we write software, that we didn't have to, we would just think of data structures that are just basically, objects that are always hot. Now, the realities of, hardware and so on, we know we need to persist data and things like that for recovery, but from an abstraction level, isn't it possible to have better, higher levels of abstraction to do this? And that's what I was working on that was doing this, which inspired this talk. So this is kind of the way we've been doing computing and persistence for a long time. But there's this software abstraction. So let me just give you a quick introduction to this, kind of the fundamentals of this abstraction. So the idea is that there's this concept of an entity, and an entity is a unit of data. It has an API of some kind, and it has some code and some state. So another way to think about it, think of it as a stateful, durable object. So that when your system's running, it's pulling in all these instances of a particular type of entity, say like a shopping cart, right? So there's, say, hundreds or thousands of people hitting your shopping cart system. Every shopping cart on the back end has its own instance of the shopping cart as a durable, persistent object. This is what these entities represent. So there's, so the business logic and the state right there. Of course, the business logic is all shared, but this, the state's unique for each instance of a entity. So commands flow in through the API, perform some kind of business logic, and do some kind of a state change, and you emit the state change, which gets stored. So let me just show you an example of what I mean by this in code and how it works. And there's an API. This is the implementation of an entity using, I'll tell you what this is at the end. But the trick here is right in this. Is this too small? Zoom in. Trick is this create order item, okay? There's two parameters that are passed to it. The command, some kind of create order item command, but what's also passed is the state. So what's different here is that it's the abstraction layer that is handling routing a request, routing a command to an instance of an entity, and also retrieving the state of that instance of the entity from wherever it's storage. But for you and I as developers, we're not dealing with that. There's no database connection here. There's no database transactions here. What's happening is that the abstraction layer is handling the state. So it's retrieving the state and it's passed in. So now the abstraction layer has simplified our lives a lot because I'm not writing all that other extra code. Basically, all I'm doing is writing the code to handle the command. Validate is the command OK, make some kind of a state change. And the way where that happens is down in this handle method. So the other end of this process is that there's the abstraction layer, which I've kind of inherited from an abstract base class here in Java, is there's a update state. So when I've run my business logic and I've updated the state, like added an item to a shopping cart, then which is happening in this method, it's just updating a shopping cart, no big deal. But all I'm doing is saying, all right, hey, abstraction layer, here's my new state. You update it. So now again, the abstraction layer is responsible for putting that state change in some kind of persistent store. What that persistent store is, I don't know. How it works, I don't know. I don't care. It's not my responsibility anymore. This is kind of just a peek at what I mean by this abstraction layer that's kind of trying to remove as much complexity as possible and lets me focus on kind of the core functionality of the application that I'm building. So that's one example. Another one that I think is more interesting is that that was kind of a CRUD-like entity. You know, it gets a command in, it makes a state change, and the whole state is saved as a single update or something. Here, this is an entity, but it's an event source entity. So the only real difference here is that commands come in, the code gets executed, but what we're emitting isn't the fully updated state. What we're emitting is just the events. And those events then get persisted down into an event store. So I've got an example of that. It's just a different implementation. This is a shopping cart implementation. And this one's a little bit more, there's a kind of a validation method. This is just the way I wrote the code, this reject on this line that I'm highlighting here. It rejects just my form of validation. It returns an optional, and if it wasn't rejected, then it's just going to invoke this handle method. And in this handle method, the only difference is instead of doing an update state, I'm just emitting the event. That's all I have to do, and then the event gets emitted to some kind of event journal. So again, the state was passed into, with my command, retrieved by the abstraction layer, processed my logic, and then I'm emitting events. So that's all I'm focused on here. Now, there is a bit of a difference here. If we go back to beginnings, damn these screens that are so small. You can see that there's methods that have to be implemented for the different commands, like you can see add item, change item, remove item, and so on. You know, things you would expect to see for some kind of a shopping cart checkout. But there's also methods that I have to implement that handle the events. So what happens is that the event is emitted back to the abstraction layer, and once the event is successfully persisted in whatever it uses for the event journal, it comes back and then it invokes this other method which passes in the state again, which hasn't been altered yet, and the event. So now it cycles back through my entity, and what happens is that there I'm just doing an update state. I'll go to this one. And all this method is doing is, it's taking that event, altering the state, and then it's just returning it. But again, no database connection, nothing like that, no transactions. It's just kind of pure eventing and state changes and business logic. So now it keeps kind of going because, often with event sourcing, you have CQRS, Command Query Responsibility Segregation. So there's views. So there's views that are being generated from the events, and say with an event sourcing entity, that the data is being projected in those views. Now the way that works is that there's something that I have to implement, or, we have to implement as a developer, but basically what we have to implement is we have to implement methods that consume those events. So these events are they're put into the journal, and then as quickly as possible, they're also being pushed to downstream components like views and being fed into code that has to transform those events into however the data is being persisted in the view. So there's these transformation methods. But the point here is that in this case, the state that's being passed in is I should have called this a row. It's the row from the view for this event. And so for this event, this is the row you want to change. Go change it and then give it back to me. So the mechanics of retrieving events from the event journal, right? All that stuff is being handled again by the abstraction layer. I'm not, and these changes are just being pushed to my code. So it's kind of reduction in complexity that's happening here. And it just, it goes on. So, these commands can be coming in from the typical, some kind of a client, but it could just as easily be, because the entity doesn't care who's sending it the commands. All it cares about is what commands it gets, and it has to process those. But another common source, say, is data coming in from some kind of a topic. So there's kind of a third player here. I've talked about entities. I've talked about views. In this abstraction, there's a third player. It's called actions. And actions are kind of like stateless functions. So these actions are being fed messages from a topic the action is thing that transform those messages into commands that it feeds into downstream components like an entity here. And I'll show you an example of that a little bit later of an action implementation. But this is where it really gets fun. And this is where this new way of doing things kind of rocked my world a lot, in that now I started doing things like stringing entities together in event-driven flows. And so in this example, say the shopping cart, which is an event source entity, it's emitting events into a journal. Those events could be being picked up and processed by views, but those events can also be picked up by a downstream action, which takes those events and transforms them into commands to feed to a downstream entity. So it's like, for example, say there's a checkout. And when a checkout occurs, it's like, we got a real shop, we got an order here. It's not somebody playing around with a shopping cart, putting stuff in and just shopping. They hit the buy button. So now we need to fulfill that order. So that's a significant event. So that event is picked up by an action, which then creates an order for that checked out shopping cart. But the picture gets more fun, which I'll show you a bit later on. But this is, again, where things get interesting, where you have this kind of cascading sequence of events that can occur. And it's the simplicity of doing things because the abstraction layer is doing so much work for you. Now, again, hammering home, these entities, again, think of them as objects. There's an instance of an entity for every single state. The system's doing things like, this is a stateful system, but we're not really responsible for dealing with that on the development side. It's the abstraction layer that's doing it. So it's doing things like, once it's retrieved the state from the database and made it hot, it's going to keep that state in memory as long as possible until that state's no longer being changed, or it could be because the state where it was at failed and it has to be recovered and moved somewhere else, in the cloud, in the cluster or something. That's all the responsibility of the abstraction layer. Distributing entities, scaling out the underlying infrastructure to handle all the entities, scaling out, scaling back, all that's being handled, error recovery, failure recovery, all that's being handled by the abstraction layer. In the code, just writing your entity, got to handle your command, handle your state, emit events or update your state, those types of things. So there's that. So the part that inspired this picture was this concept of microstreams. And I know that I was surprised because I searched for the term microstream when I was preparing this some months back and thinking about this talk. And I did a search to see, well, who's used the name microstream. And there's actually somebody out in the exhibition floor. Their company's microstream.one. So they do some really cool stuff. I talked to them earlier today. But I like this term here because now I'm thinking of, say, an application which is composed of a bunch of services. These entities, I also think of them as like tight, concise microservices. And a full system works together with this event-driven type of approach. So I'm going to walk you through quickly how this one works. So what happens is, like I said, when a shopping cart gets checked out, that's a significant event, which is picked up by an order. So the order gets and goes, I need to create an order. So an order gets created. When an order gets created, it's an event source entity. It emits an event, which is interesting to two other downstream components. Now, the beauty of this is that the shopping cart knows nothing about order. Order knows nothing about shopping cart, and it knows nothing about what's downstream. All each of these entities know is what commands that come in and what things do they emit. That's it. That's their sphere of responsibility. So there's this loose coupling between everything, which is one of the things we've been saying is really important with microservice types of applications. So the order emits events that are picked up by this order item, and the more interesting one is the shipping order. So the shipping order picks up that event and creates a shipping order. Now the shipping order in this demo, and the link to the demo, it's in GitHub. It's under my name, my user Mckee H3, and it's just order processing Java demo written in, it's the code's all there. What the shipping order does is to say you have an order that has 2 items, and item 1 has a quantity of 1 and item 2 has a quantity of 2. What'll happen is that when the shipping order is created, it's picked up by this thing I call an order SKU item. But 3 order SKU items are going to be created because there's 3 physical items that have to be allocated. Stock has to be allocated for that in this order. So 3 order SKU items get created. When those order SKU items get created, they emit events that are picked up by the stock SKU item. And this is where kind of the most important part of the system happens, because the trick here is that I don't have atomic acid transactions. Normally, the way we would do this is you retrieve the order information, you retrieve the stock information, you perform some kind of a transaction and commit it. It's all done as some nice multi-table type of database operation. Here, the only thing I can change within an entity is the entity itself. So they have to come to a mutually agreeable set of state changes between the two. But it's done through eventing. So what happens in this situation, though, and this is where I want to show you a diagram, is that here's the order SKU item on the left and the stock SKU item on the right, and there's an action in the middle. The action does a little bit of more than just taking an event and creating a command. What the action does is it queries a view, and it queries that view to find out, are there available stock? Is there available stock for this particular SKU item? And if there is, then it will build a command and send it on to a specific stock SKU item so that they can allocate that piece of stock. If there isn't, that action is going to go back and send a command back to the order SKU item and say, hey, put yourself into a backorder state. Now, the other thing is that all the messaging here is, because it's being driven by these journals, they're effectively topics. I think of them as topics, just like a Kafka topic. It's offset driven, is pulling, things that need to be processed is pulling. So the message delivery here is at least once. So failures and everything are not an issue here. Things can break and go down and come back up. When it comes back up, it's just going to pick up where it left off. The only thing we have to deal with at the development side is the operations have to be idempotent, because with at least once message delivery, the situation is that means that you could get the same command more than once, and your code has to be able to deal with it. When I first heard about this, I thought, oh man, idempotency, I never had to do that before. Is that going to be hard? It's actually, I've been finding it's not as hard as I thought it would be on a case-by-case basis when I was dealing with it. In fact, it was getting kind of fun in my unit tests. I was writing all kinds of unit tests, and I would always have in my unit tests idempotency tests, sending the same command twice to an entity to make sure it behaved the way I wanted it to behave. So the flow doesn't stop here. The stock SKU item, if it is picked to be allocated to an order, it changes its state, emits an event, and those events are being picked up by the stock system, the stock order as I call it. So it's just kind of showing how the stock has been used. But it's also going back to the order SKU item and saying, yep, I got you a piece of stock. So this particular piece of stock is allocated. And so the order SKU item, it emits an event. Now it's going kind of back upstream. It goes back up to the shipping order and saying, yep, part of the order has been, we found some stock for it. And then what the shipping order is doing is that when all the items in the order have been allocated stock, it's been emitting events, but one of the things it's going to do is the order fully stocked. And when it's fully stocked, that's also an event that gets submitted by the shipping order, and these events are going back to the original order entity. So the order entity is getting updated as stock is getting allocated. Now you might look at this and go, oh my gosh, there's a lot going on here. There's all kinds of things happening. I remember when I was showing this internally at my company, and one guy said, well, that looks kind of brittle. And I said, no, it's absolutely rock solid, because again, there's that guaranteed at least once message delivery. And that kind of changes everything. So, this is kind of it's not brittle for sure. That's the main point of it. The other thing is it's very, very highly concurrent, because if there's smaller units, less, the database transactions. Of course, there's database transactions that are occurring, but they're smaller. There's like, I can only change a stock SKU item at a time. I can only change an order SKU item at a time. I can only change, a shipping order. I can't do joins, basically. So this is happening, again, there's hundreds or thousands or even millions of instances of these entities all running, in parallel, and things just, happen, at a high level of concurrency. So that's this order processing demo. The other thing I wanted to show you is another demo, and this is more of a proof of concept that we did for somebody that was a lot of fun. And we actually were getting ready to do some performance testing with it, so that'll be interesting. But this system, what it is that it's a merchant transactions are flowing in from some kind of external topic. And it could be tens of thousands of transactions per second. So it's really, really high volume. And what the system had to do is it had to do periodic merchant payments on the other end. So all this raw data is flowing into the system from these transactions. And all this raw data had to be aggregated into specific merchant payments. So there's thousands or tens of thousands of transactions flowing in for hundreds and hundreds of merchants, at a very, very high rate. And the system had to be doing all this kind of, aggregating or reducing to period, like say every 8 hours, it would have a payment for one of the merchants. Whatever the merchant wants, I guess, is what the requirement is. So the way this system works, it's all event source entities. And it starts with, each arrowhead in this diagram is an action. So it's kind of a simple diagram. But this was kind of the design that I used of the system before I implemented it and revised it as I was implementing the system here. But there's transaction entities that are receiving the message, here's a new transaction, here's a new transaction. So they're coming at a really high rate. So the transaction entity is very, very busy. There's lots and lots of instances getting created all the time, thousands and thousands per second. But then what happens is each of those transactions are emitting events, and now things get kind of translated into merchant space. So now what we're tracking is there's sub-second entities for each merchant, and it's a specific unit of time. So the time, a sub-second in this current implementation is a 10 millisecond window. So what the sub-second is doing is it's just accumulating all the transactions that happen in a 10 millisecond window for a given merchant. And it's just holding them there. It's like, these are all transactions that haven't been aggregated yet. But as soon as a sub-second gets its first transaction, the concept is that it's activated. So it emits, when it's activated, it emits an event that is picked up by its associated second. And the associated second goes, I've got a sub-second that's got data that hasn't been aggregated yet. So it just kind of makes a note of that. So each second knows which sub-seconds within its time span have data that hasn't been aggregated yet. And it just works its way up a tree, or kind of down a tree, because the transactions are kind of leaves here, and the branches go down the tree. So because when a second gets activated, it'll activate its associated minute. When a minute gets activated, it activates its associated hour to its day, and then it goes to the merchant. And when the merchant gets it, goes, okay, for this merchant, tells the merchant, okay, we got some data to aggregate. Now, what the merchant's going to do then is it emits an event. This goes back to the day and goes, hey, day, aggregate what you got so far. And it just works its way back up the tree, because day goes to any of its hours that are active and goes, hey, hours, aggregate your data. Hey, minute, aggregate your data. Hey, second, aggregate your data. Now, this gets very, very concurrent, because while these things were kind of bubbling down the tree up to the, down to the merchant, transactions are still flowing in. Transactions are getting created, sub-seconds are getting created, seconds are getting created. All this bookkeeping is happening at a very high rate, high level of granularity. But the merchant kind of goes back up the tree and goes, all right, whatever hasn't been aggregated yet, let's go aggregate it. So when it gets down to the sub-second instances, the sub-second goes, okay, I'm going to sum up what I got, emit an event with that sum. I'm going to set myself into an inactive state, and I'll emit events. And so it's going to emit events for all the transactions that it just aggregated to tell those transactions which payment they're in, and they have been paid. It's also going to give the sum to the second. So it goes, when all the sub-seconds that are active within a second report in, the second goes, okay, I've got all my data, I'm going to sum it up, and it just works its way back down the tree and goes to the payment. So now what's happening here is that all day long, for all the merchants, there's kind of this oscillation that's occurring back and forth in this tree. As data flows in, it takes like seconds for it to propagate all the way down the tree because of just the way the eventing works in the system right now. But that's okay. And a merchant gets told, hey, yeah, we got some data to aggregate. And the merchant goes, yeah, okay, aggregate the data. So it works this way back up the tree. So when I first started working on this, I didn't think about this oscillation capability that existed until I actually had the design implemented and I was testing and we were thinking of having to use a timer or something, like how do we trigger periodic aggregations? Because what we want to do is, the big problem they had with the system is like, when you do a payment, what do you do? Kick off a big batch operation, or how do you keep aggregating all this data all the time so when you do a payment? And that's what they've been struggling with this application, I guess, for a while. So here it's kind of this natural oscillation that's occurring back and forth in the tree. Every few seconds is sweeping the tree and pulling down all the data that needs to be aggregated and just summing it up. And when somebody asks, well, wait, I want a payment now, let's go, yeah, well, here's your amount, right? It's kind of instantaneous. So that was this design. So the idea here is that it's, I started this talk with the end of the data ice age, but it's kind of working out where with this abstraction layer that I'm using, it's more of a kind of a frictionless abstraction, because the cool thing was in these designs, I was able to spend almost all of my time and like intellectual cycles just thinking about this eventing design and not being bought. I've spent like, before I started working on this stuff, I've spent like the last couple of years doing Kubernetes applications. Love it, it's great stuff, but it's like I got to learn stuff about Kubernetes. I got to learn stuff about all these different cloud services I have to use. I got to learn, YAML. I got to learn this. I got to learn that. All these different things. And by the way, you got to design the application and implement that. Here, the equation was really changed to where, like I said in the beginning, why in the world, in the third decade of the 21st century, are we still dealing with all this crap? And I actually came across, this article came across, not recently, this guy, I think it was something like, I'm out of the serverless cult. After 5 years, I'm out of the serverless cult. And one of his complaints was, it wasn't so much against serverless, although everybody seems to complain about cold starts with serverless. And there's no cold starts in this system either, by the way. But it was all the other stuff that he had to deal with just to build a serverless application. So it was, the serverless code is cool and easy to do, but I got to do, all these cloud services and all these other things that he talked about in his article about what he had to do. And saw another article. It was how much time, most of our time is spent on trying to understand the system, because most of our time is spent on maintenance. And and I think, I was kind of interpreting it from my perspective, but it was like, when you go into a system that you didn't write, which is often the case when we're doing maintenance, or you wrote it, but it was 6 months ago, and you're looking, who wrote this crap, that type of thing. But it's just, you got to go into the application, and it's not only that you have to try and understand what the application is trying to do, say at a business level, but you're trying to understand all the technologies that the application is using. That's what keeps us busy and gainfully employed. But so here, the abstraction layer, it's not just that it's kind of abstracting away the database, and it's abstracting away things like brokers and Kubernetes, ops, database, cloud services, for example, and it's serverless. But it's all those things are there. All those technologies are being used, but it's within the abstraction layer. So kind of the call to action here is that it's time. It's kind of like from this perspective, there's two types of development. There's application development, the things that I spent most of my career on, I think many of us do. But then there's also tool development, or framework development, or product development. And it's fun for my job because as a developer advocate working for a company that creates stuff, I'm in the middle. So I get to talk to people doing, trying to use our stuff and use other stuff. But I also I get to go back and yell at the engineering team and say, we need this feature. These guys were complaining about something, or had a really good idea of something we should do. But I think it's like we shouldn't take things for granted. It's like one thing that kind of should be challenged, I think, is the 12-factor app where, of course you do stateless. And I've seen this in discussions that you see online, people talking about, the only way you should build these kind of backend apps is with stateless. It's like, no. Do you really like doing it that way? Don't you think it could be done better? Yeah, I think it is. And so it's the good news is I think that there's more of this happening across the industry, but it's something that we should really be pushing. And it's like, for me now, having kind of gone into the through the looking glass or whatever, I don't want to go back. I write these apps. And even right now we write them, and you build a Docker image, you deploy the Docker image. Right now I'm complaining, why do I have to use Docker? Why are you telling me I got to use Docker? I don't want to use Docker. I want to build my app with the least amount of drama and friction as possible. Give it to you, and you run the darn thing for me. Now, and it's like, well, should I complain? It's like, I'm on one side I say no, I shouldn't complain because I build this app, I deploy it, and about 2 minutes later, the whole thing's running. All the database is ready to go, all the systems ready to go. This thing's ready for production. About 2 minutes after a cold deploy, right? No setup, nothing, zero. And it's running in a Kubernetes environment, running with all kinds of other tech, and it scales, it's resilient, all that good stuff. 2 minutes, and I'm complaining because I could use a Docker image. But I think we should, because if it's something that's kind of distracting you from the actual core implementation of the application, we should be complaining about that. We should be trying to remove that friction from our development processes. So I think it's, like I said, the inspiration was the end of the data ice age, and the reason I use this picture is that these little, this picture's, again, it was from Blender, and I saw a tutorial. This guy did this, he does these really cool tutorials, and when he did this, and I said, oh man, I got to do this one because I want to use it for my slides. And it's Blender, again, like I said. Blender just introduced something new they call geometry nodes. If you want to see something really cool, like a very cool, powerful abstraction, look at this new feature that they implemented in this Blender. It's a way of programming that generated all this stuff in my picture, all these spheres and lines and connecting it all up. I just wrote a few things and then poof, it's there. It's like ultra cool. This is the kind of tooling that we should have, for building our applications as well. So I just want to wrap up with, I love this statement. Any sufficiently advanced technology is indistinguishable from magic. And this is from one of my favorite authors, Arthur C. Clarke. And the reason I like this one is that I kick myself over and over and over again, and I think now that I've been doing this for a while, I'm getting better at it. But you see something new, and it's like, oh, this feels too magic, too something. It's like, nah, that doesn't smell right, and I don't pay attention to it, and I end up regretting it. And I go back, eventually I'll wise up after everybody else it seems has figured out that this is something that's really important, and I'll start taking a look at it. This is something new, this and the point that I'm trying to get across is these more powerful abstraction layers that are starting to emerge that seem like magic at first, but they're not, and they just kind of lift the playing field. And we have this long history in computing. Like, if you ever read about like going from programming in zeros and ones to assembly language, there was a lot of moaning and groaning about that. From assembly language to like C, there was like, oh man, you're taking away all my control. It's like every time we kind of lift the abstraction, there's a massive amount of resistance, and ultimately, the best things kind of emerge and win. I see these kind of more powerful abstraction layers like this as the next big evolutionary jump. And I'm all for it because, like I say, I don't want to go back to all the friction drama of what I had to deal with. And this is with modern stuff like Kubernetes. Kubernetes is great. I'm not bashing Kubernetes. I love Kubernetes. It changed everything for us in some wonderful ways. But it's kind of like now it's the assembly language. Let's put some really nice layers on top of that. So that's it. So what I've been talking about is, you can see on my T-shirt, is called Calyx. It's a platform for doing, the code I wrote is Calyx code, and Calyx will be officially announced next week. I think it's the 17th. But I got permission to kind of say we've been doing this for about 3 years now. It was called Akka Serverless, but now we've rebranded it. And I like the name. Calyx is a river in Sweden. Akka is a mountain in Sweden. The creator of Akka, Jonas Benner, who's the CEO and CTO of our company, he's Swedish. So we hired a firm to come up with this new name. So it's just a name, but it's way better than Akka Serverless. Akka Serverless had too much baggage. We were finding. So anyways, it's called Calyx. It'll be calyx.io next week. So take a look if you're interested. But there's other things like I don't know if you guys have seen Temporal. Is another one that's really interesting as well. It's similar. It's a higher level abstraction. Really cool stuff. And there's more stuff like this happening all the time. So that's it. Thank you very much. We have time for questions, if anybody has a question.
Thank you, Hugh. It's a great talk. One of the most difficult things, I think, during dealing with event sourcing is when you get your modeling wrong and you need to migrate to a new data model and change schema. So how would Calyx resolve that once you up and running in production with a lot of data in the background?
Yeah. So I think there's the quick way if you're lucky, and then there's the way that might take a little bit more time. The quick way would be if it's you can do schema migration and it's forward compatible, but that's if you're lucky. When you need to do some kind of massive changes, I think another way to do it would be that you can stand up a new service, a new in this term entity, and rig it to consume all the old events so it catches up. This is the beauty of event sourcing, that you've got all your history in the old data structure, stand a new one up on its side. It's not live yet. Let it consume all that data and catch up. And once it's synced up, then you can turn off the old one and bring the new one online. The thing I like about doing it with this higher level of abstraction is that, again, it's like, okay, yeah, we got to do a new entity. Okay, well, let's design a new entity. All right, let's deploy it and see what happens. Like I say, do a deployment. 2 minutes later, it's up and running. It starts consuming data. You can test it out. If you don't like what's happening, okay, let's blow it away and we'll do it again. It's that whole, it's like, oh man, we got to set up another event journal. Oh man, that's, I got to set up tables. I got to do this. I got to do that. All that friction, all that drama that is typically associated with it because we're using all these different services, all that goes away. When that goes away, it's liberating. It's like, yeah, okay, let's change the design of the system. No problem. We'll stand up new entities or new views. Same thing. If you want to significantly alter a view, well, keep the old one, start up a new one, let it catch up, and once it's caught up, then bring it online. And all you got to do is wait for it to catch up. Now, depending on the volume of data, it could be a while, but it's doable.
I have one more question. So we're gaining a higher level of abstraction and a little bit more magic. So what insights do we have for the system? Do we have visualization or anything?
That's an area that we're weak on, at least in Calyx right now. Because it's new, and I think we're going to need we're going to need more. It's like one thing we were talking about was like those diagrams I showed you. Those are just something I did, and if you look at Temporal, for example, they have a really nice workflow tool. So you actually write code for the workflow. They're very workflow oriented. It's pretty cool. But one thing we talked about was that that diagram that I drew by hand is derivable from the definition of the system. So probably doing a modeling tool could take a lot of engineering to create. But doing something that could just look at the definition of the system and visualize it could take a lot less effort. So I think that's where the engineering team's thinking of going right now. But this would be one of the things that the development community would come back with and say, hey, are you kidding? We need visualization here. I can't see what the system looks like. I can't see what's going on. Another thing is like, are there log jams? Is there some entity that's running slow or broken or things like that? These are still areas, honestly, that we still have to address. But they will absolutely be addressed because they're absolutely necessary.
Thank you.
Thanks. Any other questions? Just a question for you guys. How many have done any kind of event-driven or event sourcing type of development? A few? Is event-driven and like things like CQRS, are you familiar with it? Have you looked at it? No? I'm sorry, because I glossed over CQRS real quick. And it's a whole thing. I've done whole talks on it. Other people have done whole talks on it. There's books on it and everything. Even internally, I've been, I'm the guy doing all the eventing stuff, is what some of the people in my company are saying, because I'm just kind of nuts over this stuff. But because we have 3 minutes, so I'm going to use it up. But it's like, we've been talking about it for so long, but there were so many kind of complexities, inhibitors to doing it, that it was hard to even experiment. With this, it's like, if you want to learn about event sourcing in CQRS, if anything else, take the free trial and just play with it, because you'll be able to do it, experiment with it, deploy it into a production environment, and run it. Basically, it's ready to go. If you don't like it, blow it away and redesign it and deploy it again real fast. And this is what I was doing. Like I said, realizing that I could implement this oscillation back and forth. I didn't realize this until I was deep into the implementation of this. And say, oh my gosh, I got auto aggregation without having to use things like timers or something. But once I started really wrapping my head around this whole event sourcing thing, now it's hard for me. You know how it is. You get a new hammer and everything's a nail. Well, I've got a new hammer, and the nails are events. So it's hard for me not to think about building a system without thinking of it as these cascading sequences of events. And I didn't do a picture, but I seriously thought about it. If you look at how the nervous systems work, how, natural neural networks work, this is how they work. Things cascade through multiple layers. I mean, this is very far away from that, but this feels more natural. It feels more intuitive, this whole eventing type of a way of doing things. I can't wait to try more problems with this and work with more customers on it. So a lot of fun. So I think time's up. And again, delighted to be here at Devoxx. Very honored. And thank you for being in this last session after a very long day. I appreciate it.